hydrostatic particulars. You must have
Yes.
seen this in Hindship, right?
Yes, sir. Yes, sir. Right.
So first of all, we need to understand these terms. What is
Okay.
this draft BK?
Hmm.
Any idea?
Sir, no idea. Keel from uh draft BK.
Yeah, because the terms are a bit fancy, the
Yes, sir.
names, so people get confused.
Yes, sir.
Actually, this is nothing but hydrostatic draft.
Okay. Okay.
You can say BK is below keel or base.
Yes, sir.
Whatever.
That's why I got confused.
Okay. And the second term is displacement.
Okay.
Third is TPCI, or you can call it as a TPC.
Tons per centimeter.
And you know what is the meaning of TPC, right?
Yes, sir. Tons per
Per
centimeter.
centimeter, right? Suppose
Yes,
the
sir.
value of TPC is 21, it means if I load 21 ton, it is going to immerse by 1 centimeter.
Yes.
All right.
Okay.
Then there is something MCTC, that is movement change the trim by 1 centimeter. That means it depends how much movement you are going to create. And if you create whatever movement, it is going to change the trim by 1 centimeter. All right.
Okay.
LCB, that is longitudinal center of buoyancy from
Forward of half perpendicular.
forward of half perpendicular. So suppose your vessel is like this,
Yes.
and there is a center of buoyancy here. This is taken from half perpendicular. By the way, this is propeller.
Yes,
This
sir.
is what it is. Similarly, there is LCF. LCF is longitudinal center of flotation. Do you know about COF?
Yes, sir. Center of flotation. I know.
But how it is defined?
So center of flotation is the center underwater, the center of the underwater volume of the ship.
Okay. Let's define it further. The
Jim-
COF, center of flotation, बहुत important चीज है ये.
Yes, sir.
Suppose your vessel is like this, and I'm not
Okay.
talking about box shape. I am talking about ship shape.
Okay.
Now, wherever is the water line,
Yes.
so if I cut this section, it will look like this somewhat.
Yeah.
Right? So the geometrical center of this is COF.
Geometrical center of water plane area.
Geometrical center of water plane area. Correct. That is center of flotation. And why it is important? If it is a box vessel,
Yes, sir.
very easy. If
Yes,
it is
sir.
box shape vessel, we will say
It will
that
be
is midship.
Yes, sir.
But due to ship shape, it may or may not be a midship. Make sense?
Yes, sir. Makes sense.
Because geometrical center, because of the shape, maybe it is slightly larger this side or slightly larger this side, whatever the case may be. Then VCB, इसमें सबसे ज्यादा कंफ्यूजन होता है. This is vertical center of buoyancy. Actually, this is KB.
Okay. Okay.
And this is KM. The
Okay.
one
Meta-
which we use, KM meta center.
Yeah.
This KM, this is used in conjunction with MCTC and trim. This is longitudinal meta center.
Okay.
Okay. So there has to be two meta center. One is transverse, another one is longitudinal.
Longitudinal.
transverse is like this. Suppose your vessel was like this and it is healed. This is the center line,
Yes, sir.
right?
Yes,
And
yes.
when it starts healing, suppose it heals like
Mm.
this, then there will be force of buoyancy here,
Yeah.
and the weight will act vertically downward. This is M.
Yes, sir. Yes. Mhm.
This is transverse meta center because we are looking in the transfer direction.
Yes.
Now, similarly, suppose your vessel is like this,
Mm.
and there has to be a center line here, and
Mhm.
suppose she trims. Suppose
Okay.
she trims. Then force of buoyancy on water line is like this. Maybe the
Center of rotation.
center of
Yeah.
buoyancy is here. It cuts here. That is M. And since in this longitudinal direction, it will be close to in hundreds, multiple of hundreds. Look at this
Mhm.
value,
Yes, sir. Yes, sir. It will be in hundreds.
around 400,
Mm.
391, and so on. And this
Mhm.
km in transverse direction, it is pretty small, around 10, roughly
Okay.
in the order of
Because of the length of the ship, right?
correct, correct. So these are hydrostatic particulars which are given on page number 7 and 8 of Hindship.
7. Yes, sir. Can see.
And one more bottom line is they are tabulated only for salt water.
Yes, sir. Only for salt water.
Okay, chalo. So this is the kind of template I had created,
Okay.
and actually these are, first is hydrostatic draft, second is displacement, hydrostatic draft, displacement, then the TPCI, actually is TPC,
Mhm.
then this is MCTC, next is LCB, this VF,
Yes, sir.
that is actually KB,
KB.
vertical center of buoyancy, VCB or KB, then KM, KM transverse, actually you can write T also, and KML.
Yes.
So how many particulars are there? If you see carefully,
Yes.
if we
Hydrodraft.
count, there are 9 each.
Yes, sir. 9. There are 9.
So remember, they are Akbar's Navratna, right?
Yes, sir. No, that's
The
fine.
entire stability is going to depend on these 9 parameters.
Okay.
1, 2, 3, 4, 5, 6, 7, 8, and 9. And all these parameters are tabulated against hydrostatic draft.
Draft.
Now the $1 million question is, what is hydrostatic draft?
Sir, hydrostatic draft is the sir. It is the draft at the center of the flotation, from the center of the flotation of the ship to
Correct.
the main draft.
Correct. So this is your vessel, just showing off with the propeller, and wherever is the center of flotation,
Yes, sir.
that draft is going to be hydrostatic draft. Basically, draft at
Center of the flotation.
center of flotation. All right. So there is a, like, these particulars, sometimes they are okay. As I said, these particulars are tabulated for 1.025, that is salt water, right?
Okay.
They are tabulated for salt water. But
Okay.
now, if a water is a different kind of density, then what we have to do?
Dark water allowance, freshwater allowance.
Yes. So we really need to understand these terms, and accordingly, we need to identify. So here, I'm just showing you one example, and please pay attention, and we'll be writing some notes.
Okay, sir.
Suppose the density is 1.015,
Okay.
where we need to find out. Okay, so that is actually dock water, right?
Right.
Why it is dock water?
Because the density is less than 1.025.
Anything which is fluctuating between relative density 1 and 1.025 is dock water.
Okay.
What is given in your tablet, or the booklet, Hindship?
So it's 1.025.
1.025. That is salt water, 1.025.
Yeah.
So we need to convert. All right.
Right.
Conversation, we need to really understand the entire basics of stability. And since you have already done, so I'll go easily. So what we say, and suppose it is given at 5.6. I'm saying my ship's draft is 5.6 in dock water.
Yes.
Okay, this is given.
Hmm.
Hydrostatic draft in dock water is given. And suppose this was given 5.6.
Hmm.
Obviously, the value of 5.6, this 1120, 22.32, 171, 72.92, ये किसके लिए हैं? These
Dock
are
water.
for,
Dock water.
no, these are for,
Also, from the Hindship, yeah, these are from all Mossy
correct.
water. Okay.
These are for salt
Water.
water.
Yeah.
These are not for 1.015. By the way,
Yes,
numbers
yes, yes.
are, don't get confused with 1.025 and 1.015.
Yeah, yeah.
Hmm?
Yeah.
So let me just clear it off. So we have what is given here. We know this, and when value of 5.6 is given here.
Okay.
So what we say, let's assume we are having the same here.
Okay.
Let's assume.
That's it. Okay.
Okay, and then I will show you that in that stability there is a problem which does talk about it. So many guys don't pay attention, but never mind. Now here what we realize, suppose this is the value we wanted, and we assume that the salt water is having the same.
Okay.
So in both these density, that is salt water and 1.015, what I see common if the draft is same, suppose if I am just writing like this, and this is salt water, this is 1.015 or dock water. And if I am saying both the drafts are same, that means our underwater volume is same.
Equal, yeah.
Make sense?
Yes, that makes sense.
And if underwater volume is same, what is the displacement? How do we say displacement?
Displacement will be
Displacement is
also the
equal
same.
to underwater volume into
The
relative density.
Relative density. Okay.
And this is constant. So displacement is directly proportional to
Relative density.
make sense?
Yes, that makes sense.
So for 5.6, you have this displacement, which is given here.
Yes, sir.
Now what we have to do, we have to work back and we need to find for 1.015.
Yeah.
Directly proportional to density.
Yes.
So जिस proportional से density के है उसको multiply करेंगे.
Okay.
अगेंस्ट है
Method.
उससे डिवाइड करेंगे. सीधी सी बात है. इस कॉलम में निकाल रहे हो तो इस कॉलम से मल्टीप्लाई करोगे.
यस सर, उससे डिवाइड कर.
और ये वाला कॉलम है स्टार्टिंग कॉलम में, तो इससे डिवाइड करो. इज इट क्लियर?
यस सर.
And we have divided and we have got the value, whatever. Okay. That I don't want to waste time, that you can do your own calculation.
Yes, sir.
You can take the screenshot of this.
Yes, sir. Okay.
Perform yourself. It's just punching. This is a manual calculation.
Okay.
Basic intention is we need to understand the basic principle.
Okay.
So here, the first principle, let me repeat. Hydraft is same. Hydrostatic draft is
same. Okay.
That means underwater volume is
same.
That means under displacement is equal to
underwater
volume
into relative
relative
density.
density. And I hope you understand the term. That
Yes,
will
sir.
be
Yes, sir.
cubic meter. That will
Yes,
be
sir.
actually no unit,
Yes, sir.
but density has
Well,
the unit ton per
yes,
cubic
sir.
meter.
Ton per meter cube.
Correct. So that basic you should be knowing. So displacement is directly proportional to relative density. So simply, if it is proportional and we need to find the value here, then we need to multiply here 1.015 and against this value. So we have this. Clear?
Yes, sir.
Now we come back to the next TPC, ton per centimeter. So what is the formula for TPC? TPC is equal to water plane area. Any idea?
Sir, I forgot.
Relative density into I'm also got it. Relative density into water plane area divided by 100.
Okay.
Okay. Or simply in this Captain Subramaniam's book, they write like this 102.5 A upon 100. Okay.
Yeah.
If you are able to recall.
Yes.
So 1.025 is relative density.
Yes, sir.
And A is the water plane area divided by 100. Why 100? Because we are talking about tons per centimeter.
Okay.
Okay. So now coming back to this fellow, TPC is water plane area into relative density divided by 100. And just now we studied that this is constant.
Yes, sir. WP is constant.
So TPC is also going to vary
Is
as
diagonal proportional to relative density. Yeah.
So here displacement is relative density. By the way, this sign of displacement is a bit controversial. Okay.
Okay.
Because most of the book we are using it, but never architecture used like this.
Oh, okay.
So don't get confused if you go for the higher study and some typical engineer is using this sign.
Yes, sir. Okay.
As long as this shows displacement, that is fine.
Okay.
Then let's talk about the next. That is MCTC. MCTC. You remember some formula for MCTC?
Sir, MCTC is something 1.025 into the density of the I cannot remember.
No. W into GML upon 100L. Something like that.
Okay.
Okay, give me a minute. Let me also cross check before we make blunder.
Okay, sir.
Okay, because at times I also tend to forget general particulars. Hindship. Sometimes on the first page they do mention. Anyway, I think I'm quite right with this. Okay. Just give me a minute.
MCTC is equal to, sir, displacement into GM longitudinal upon 100 into length between perpendicular. Yes, sir, you're right.
Yeah, okay. All right, I just wanted to cross check.
Yeah. This L is the length between perpendicular.
Okay. So now let's analyze this formula. 100 to forget it. This L definitely is constant.
Yes, sir.
LBP.
Yes, sir. Constant.
And what is GML?
GM is a metacentric center. Yeah.
So if the ship is like this, K, the G will be somewhere here.
Yes.
Longitudinal metacenter will be somewhere here.
Yes.
Right?
Right.
So KML can be written as KG plus GML.
Yes,
right?
Sir. Yes, right.
And there is another way of doing like this, that yeah, I think that's a fair enough.
Okay.
So here what we realize what we realize, this is constant L,
Yes, sir.
and this ml, kml,
Yes, sir. Yes, sir.
kml is also going to depend on kb plus bm, right?
Yes, sir. K plus B. Okay.
Eventually, if we analyze clearly, it is going to depend on this factor.
Sir, I have a doubt here. KML is equal to KG plus GML. Okay, right. But how is it equal to KB plus BM?
Suppose there is a point here, B,
Okay.
below kb plus,
Oh, okay. Like that. Okay. 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 Okay.
right?
Okay.
So what we realize in this second equation, it is going to be a function of B, and that is center of buoyancy, right?
Yes, sir. Yes, right.
And center of buoyancy depend on underwater volume.
Yes, correct.
And here we have taken underwater volume is
Okay.
constant,
Constant.
right?
Yeah.
So if it is constant, it simply means that Km is constant.
Yes, sir. KM is constant. Okay.
If Km is constant, तो भाई इन्होंने क्या गलती की जी, तो कुछ लोड वोड तो किया ही नहीं आपने, सब कांस्टेंट
हाँ
है,
सर कांस्टेंट
तो
है
ये भी कांस्टेंट है। तो अभी वेरिएबल क्या बचा आपका?
सर वेरिएबल तो सर डिस्प्लेसमेंट बचा
और डिस्प्लेसमेंट का तो तुमको पता है,
हाँ कांस्टेंट है
एमसीटीसी, नो डिस्प्लेसमेंट कांस्टेंट नहीं है, एमसीटीसी इज गोइंग टू वेरी ऑन डिस्प्लेसमेंट एंड डिस्प्लेसमेंट वेरी,
आरडी
सेम फंडा इधर लगेगा।
ओके
ओके, थोड़ा प्रैक्टिस से आएगा,
Yes,
बट
sir.
व्हाट आई एम ट्राइंग टू से इज as this is directly proportional to relative density, this is directly proportional to relative density, this is directly proportional to relative density.
Yes, sir.
We started with this,
Okay.
so we assume that this is equal to this, and for this, that this is the passport 1.025, that's all you can enter in the table. So we entered in the table, we have noted down. And now we can come back here. We are coming back.
Yes, sir.
Make sense?
Yes, sir. Makes sense.
All right. Now coming back to your friend LCB, यहाँ पे थोड़ा मुझे मेहनत करनी पड़ी, but now it's worth it. LCB is going to depend on center of buoyancy.
Yes, sir.
Center of buoyancy, what we discussed.
Under is constant. Yes.
So this fellow is not going to change.
Okay, as we will remain constant.
What is LCF? Center of
Center of
flotation. Center of flotation depend on hydrostatic draft, right?
Okay. Yeah.
So if hydrostatic draft is constant, this
Constant,
is also
then it's also constant. Okay.
Now let's move further. VCB.
KB.
Vertical center of KB. By B constant है तो क्या होगा?
KB constant.
This is constant.
This is also
No
constant.
change.
Okay.
All right. KM.
Meta center.
KM तो बताने की जरूरत नहीं.
Transverse meta center. Yeah.
Constant ही रहेगा.
ये सर constant रहेगा.
और KML ये भी बताने की जरूरत नहीं.
ये भी constant.
Constant रहेगा. तो आपके इन पैरामीटर में 9 रत्नों में से कितने चेंज होते हैं? 1 2 3 4. बस 1 2 3 4 will change, and rest 5 parameters will remain unchanged. If you enter the value of salt water, then the value of dock water will also change. So all you have to do, you need to work out with these 4 parameters. And how to work out? Simply multiply by the density, for which you need to know, divide by the density of salt water.
Salt water. Okay.
Is it clear?
This formula will apply on all the 4 parameters, right?
Correct. Exactly.